Hello, this is Andrew, and this is another YouTube video. This video is going to be part two in my introduction to cocotb presentation series. So obviously there's a part one, but you could probably skip it. In part one, I just kind of go over some of the advantages you get for writing your test benches in cocotb over just a traditional pure HDL test bench, and I also kind of briefly explain the major components of cocotb. In part two here, I'm going to go over how the simulator works and how, I'm going to go over an actual cocotb example and how cocotb inserts itself into the simulator. And really with that basically kind of tells you everything you need to know to use cocotb. So before, I go into an example, I think it's kind of good to understand at least a little bit about some of the internals between the Python and the simulator. So everything here you see in orange, um, you honestly don't really need to know when you're writing a Python test. I think understanding VPI and VHPI a little bit, at least understanding what they provide you as a user, is kind of good to know. So these three boxes here, they're connected directly to the simulator box. Those are the programming interfaces, the APIs that the simulator has to implement in order for cocotb to even, insert itself into the simulator. VPI, that's the Verilog programming interface, so obviously that's intended for Verilog. VHPI, VHDL programming interface. And then there's the foreign language interface, which you can basically ignore. This was a older interface that Questa used to implement, but now they just use VHPI for VHDL. So in the context of simulation handles, VHPI provides more information than VPI is the general gist of it, which is something that's good to know when you're choosing a simulator. GHDL, the simulator that I use for all the examples in this presentation, unfortunately implements the VPI, which unfortunately prevents you from being able to access some information when you're trying to access different simulation objects from the simulator. But I'll go into that more later on in the presentation. So the gist of this is you don't need to really worry about these internal layers. When you're in Python, you'll be writing your operations in Go routines, and you'll be using triggers to go back and forth between the Python and the simulator. So I have a bunch of bullet points here, but really, when it comes to understanding the simulator, and I do think it's good to understand at least the general method that the simulator follows when understanding how to write your Python tests in cocotb. Um, the general flow of the simulator is, you have some of a process, you have processes that run, and when those processes reach the point where they need to give up control, they may generate events. An event could be a signal changing or a time-based event. Um, any process that's sensitive to those events gets scheduled on the next cycle to run, where the priority is always on the events that are the priority is always on the processes that are sensitive to like signal events. Um, so I'm going to go over an example, and hopefully the example kind of gets this point across. So in this example, we have really simple VHDL like test bench. In the beginning, nothing's initialized, so nothing happens. The run proc process is it's not sensitive to any signals, so those always run. So 0 gets assigned to A and 0 gets assigned to B. Well, I should say standard logic 0 gets assigned to A and standard logic 0 gets assigned to B, and then there is a event. Uh, there's a event for waiting 10 nanoseconds from now. So once we get to this wait statement, A and B is going to change to 0, um, and because A and B are signals because A and B are signals, and though in line 13 is sensitive to A and B, that process gets scheduled on the next cycle, and then 10, 10 nanoseconds from now, the run proc will get rescheduled to run. So, and as I mentioned, A and B becomes 0, and then C runs because it's sensitive to A and B changing. So A, 0, and B. So obviously 0 is going to get assigned to C. So there's no processes that are sensitive to C changing. So nothing else gets scheduled, which means the time step will increase. And now that there's no more processes sensitive to signal events, then what happens next is, well, processes that are sensitive to the next time step, I should say. So it's gonna resume run proc is gonna resume control after line 19, and one's gonna get assigned to A, and then a 5 nanosecond time event is gonna get scheduled 5 nanoseconds after the current time step of 10. So because because line 13 is sensitive to A, then that's going to get scheduled next, of course. So 0 ended with 1 is obviously still 0, and because C was already 0, nothing changed, so no event will occur. And of course, this process repeats itself to the end. So I don't think it's necessary for me to go through each and every step, since the same process is the same method is followed till the end. And honestly, simulator is pretty straightforward. And if you understand how this example works, especially with how the wait statement works, then you already understand cocotb. So let me go to the end, and this is just a quick table that summarizes everything that I kind of just mentioned. Well, I kind of brushed through the end, but like I said before, the same method gets repeated over and over until we have all our information. So obviously, the main timestamps is 0, 10, and 15. So at 0, everything is 0. Excuse me. And then at 10, A gets changed to 1. And then at 15, B gets set to 1, which means, C also gets set to 1 because 1 and 1 is obviously 1. All right, so now that we have a good understanding of how the simulator works, well, let's insert some Python. So, like I said before, the Python cocotb effectively is another process within from the perspective of the simulator. But so just to kind of explain everything that's happening in this small test example, so the main imports is cocotb and then the triggers module. With these two imports, that will cover 90% of all your tests. You'll definitely be using the cocotb and triggers in every one of your cocotb tests in some manner. Either you'll be directly using them, or you'll be using libraries that include them. I also included the clock module here. This isn't necessary, but it has useful tools for generating clocks. So from the cocotb module, the test decorator is how you indicate what coroutine is a test. So in Python, a coroutine is any function that's qualified with the async keyword. And if you're making a coroutine a test, it needs to take one argument. This argument is the top argument, and this is a reference to all the simulation handles in your design. So it's pretty important to understand that the simulation handles in cocotb, they reference the simulation objects that run in your simulator. So they don't directly reference your actual, HDL. It's whatever the simulator says is available. That's what cocotb can actually access. And this is pretty critical since sometimes it can feel as though, cocotb might be limited in what it can see. Well, it's not necessarily cocotb. If you have optimizations or you don't have, full visibility enabled with your simulator, then cocotb is not going to find it because the simulator doesn't acknowledge it. So just to kind of reinforce this point, top here is referencing this, uh, the top entity. So top here is equivalent to delta cocotb example. So, top.b, since b is like within this hierarchy, um, you do top.b to access that simulation object. It's also worth mentioning. This is a bit early, but it's also worth mentioning when you're accessing simulation objects, the every simulation object or simulation handle has a dot value property associated with it. The dot value property is how you write values and get values from it. So triggers now. So triggers is effectively the wait statement in VHDL. You use them to kind of give back control to the simulator or another scheduled coroutine. And they also indicate what event that needs to occur to make the current coroutine resumes operation. So in this case, when you do a wait triggers edge top.b, you're telling the scheduler like, hey, I'm going to give up control. However, I want to get control back when there's an event on top B. So edge is effectively the tick event in VHDL. It just means that there was some type of change on that corresponding on that specified simulation handle. Mm. Okay, so now we're going to go through another example, but this time we're going to incorporate, the Python. So just like before, A, B, and C, well, they're uninitialized, so they're just going to begin with U. So cocotb, like I said, is basically another process, a process that doesn't have any input, so it actually runs first even before the processes in your VHDL. So what's going to happen is log.info, this statement's going to run. It's going to print out the current value for B, which should be U, and then it's going to hit this wait statement. And by wait, I mean the trigger statement. So it's going to give up control back to the simulator, and it's not going to resume control until there's an event on B. So print. So I'm going to show the log later, but I guess trust me when I say that it's going to print uh, B equal to uninitialized, and then it's going to the cocotb is going to get scheduled again when there's an edge on B. In other words, when there's an event on B. All right, so now that we're done with the cocotb process, now we're going to jump to the run proc process, where 0 is going to get assigned to B, and then it's going to hit this wait statement where it's going to give up control until 15 nanoseconds has passed. So what should happen is 0 gets assigned to B, which schedules the cocotb process, which will occur after the run proc gives up control. So 0 is assigned to B. So, and I completely forgot, the line 13 is also sensitive to B, so that's also going to get scheduled. And then, so cocotb is going to get scheduled, and then line 13 is going to get scheduled. And then the run proc is going to get scheduled after 15 nanoseconds has passed from the current time step. So it's going to jump back to cocotb, and it's going to print out the current value for B, which should be 0. Well, it is 0. since that's what changed, and then it's gonna hit another trigger where it's gonna say like, I'm gonna give up control back to the simulator, but I want to get back control. Please reschedule me after 5 nanoseconds have passed from the current time step. So now that that's finished, now we're going to do line 13, where obviously, um, well, I'm actually not even sure why this is true, but zero ended with uninitialized is always zero, apparently. And there's no process that's sensitive to C, so nothing else gets scheduled. In which case, well, the next timestamp is going to occur. So the next timestamp is going to be the one that's only 5 nanoseconds from now. So cocotb is going to get scheduled again. So what should happen is, well, we're going to jump to line 11 in the cocotb test, where 0 is going to get set to A, and then we're going to give up control again and then wait 5 more nanoseconds after the current time step. So yeah, and that's exactly what happens. And then any process that's sensitive to A changing is going to get scheduled. Um, and then this cocotb process is going to get scheduled again. Right, so C is going to run, and I think by now, I think everybody who's watching understands the pattern. If not, you can look through the slides and see how everything resolves. But the process once again repeats itself until we reach a point where there's no more time, no more processes to get scheduled. And here's just a table that shows what each stage, what's happening at each cycle. And here's the waveforms, and here's what the console actually looks like when you run your cocotb test. I think most of this is pretty self-explanatory. You have a log. There's a timestamp on the left that shows you at what point in time things were actually. The timestamp on the left shows you when the log was like printed, which is pretty useful when it comes to doing debugging. And then there's a little bit, this kind of like a fancy summary you get on the bottom showing you like, oh, this test has passed, or if it failed, oh, this test has failed. So that's honestly that basically covers it for this really quick cocotb example. Kind of covers what I think is like 90% of what you'll do. Obviously, I'll have to explain a bit more detail about some of the simulation handles, and there's other triggers to know, but they're triggers that you would expect to see, like rising edge, falling edge. Um, so too long, didn't read. So really, in conclusion, if you understand how the VHDL wait statements work and how process statements work in a VHDL and in the simulator, you effectively already know how cocotb works. Now it's really a matter of figuring out the proper syntax and what functions slash keywords to use. So wait is equivalent to cocotb trigger. So example, both result in process task giving up control, but indicating when the control should be reinstated. Really, this should be like when the task should get rescheduled. Um, so an example is, wait until rising edge clock. This is equivalent to await triggers dot rising edge clock. Wait after 5 nanoseconds is await triggers dot timer. Wait until sig tick event is equivalent to await triggers. This should be edge. I need to make a note to fix that, but this really should be edge, not event. Just like VHDL processes, cocotb can block the simulator indefinitely if it doesn't give up control. So I'm sure anybody who's made a VHDL test bench once before has accidentally forgotten to add the wait statement at the end of their process, and if you forget to do that, then the process runs indefinitely. It keeps looping until the simulator crashes. So unfortunately, in cocotb, it's actually worse. If you forget to have a wait on a trigger somewhere in your test, then or somewhere in your coroutine, it will just block indefinitely in the Python, which actually causes the simulator to freeze because while the Python is running, the simulator is actually not running. Something to keep in mind when you're writing your tests. And just to kind of reinforce the point, so all these statements here are the same, right? You have A and B, C. So when there's an event on A or B, then this statement runs. I know that I kind of phrased that kind of wrong. I phrased that in a weird way. If A or B changes, then you know this C statement here is going to run. And same thing with sensitive zero proc, right? So this process block basically means if A or B changes, then C this process is gonna run, which is equivalent to this statement here. Wait until A tick event or B tick event, then this will run. And all these statements are effectively equivalent to this statement, this cocotb statement on the right. Not exactly, because the statement on the right assumes that A and B are already 0 and 1. More about simulation handles later, but when you get a value from a simulation handle, it's actually a special type called a binary value, which can be converted either to an integer or a string. Um, so I always recommend trying to go from try to use an integer, but more often than not, you might be in a situation where the value that you're trying to read is not resolved to 0 and 1, which means the following this statement here, it's gonna fail when you try to convert it to an integer. But besides that failing case there, these statements are effectively the same. First is a pretty commonly used trigger. At least I use it a lot, which indicates, well, if one of these conditions occur, then we want to resume the current coroutine. So with that, I'm gonna actually call it quits on this presentation. There is actually more to this. This is actually where I stopped during the talk that I had the week before last. And I'm actually thinking about in the future maybe having a another talk because there's actually more information to kind of go over. Um, yeah, so this is a good point to talk. I've already been speaking for 22 minutes. Hopefully this presentation is uh, is as coherent as it needs to be to get the point across. If it's not, well, I mean, you have the slides to look at, and then there's examples also to look at. Um, Plus, I mean, you can just go to the cocotb repo and look at their documentation. I think their documentation is pretty good. And there's a growing community of people using cocotb, and their information is plenty useful as well. But thanks to those who took the time to listen, and good luck writing your tests.